All right, so one thing we haven't talked about at all yet is it seems like every time that we've talked about substitution chemistry, it's always been on sp3 hybridized carbon atoms. So this would be a standard primary alkyl halide, and with a strong nucleophile like sodium hydroxide, this would definitely do an SN2 reaction, which would produce that alcohol plus Cl minus. So what is the difference going to be when we have an sp2 hybridized carbon bonded to a chlorine? So what's the difference there? And so what is the difference between an sp2 hybridization and an sp3 hybridization, as this one is? And think about that for a minute. It's the percent S character, right? And as we get more S character, the bond gets shorter and the bond gets stronger. So while substitution chemistry happens very readily on sp3 carbon halogen bonds, it turns out that when we have an sp3 carbon chlorine bond, an sp2, so this is a C sp2 bonded to a chlorine, because of the greater percent S character, this bond is stronger. It's harder to break. And because of that, we actually get no reaction. It turns out that these stronger, shorter bonds just don't work in this substitution chemistry. So it turns out that there's no SN1 or SN2. So neither reaction type work if the alkyl halide is sp2 or sp hybridized. So that is one extra kind of thing that we need to always check when we're trying to understand, is this going to be SN2, SN1, neither of them, or no reaction? And that's one reason why it could be no reaction.